Okay, Bailey, I will try, but this is a little insane the night before the test. So, as far as HHI goes, look in the book, the information is there. Generally, the 2500 is considered to be concentrated. Income and substitution effect. So, you have two things, apples and bananas. You have a certain budget constraint. Let's say you can afford 30 apples and 25 bananas. Now, the income and substitution effect are both present when there is a change in price, not just when there's a shift in income. Okay, so what it means that, let's say the price of apples is going to increase. So what it means is that you can no longer afford as many apples. So let's say you can only afford 30 now with your income. So we have a rotation of the budget constraint. Now let's say originally you consumed, this was your optimal bundle, okay? 20 and let's say 10, okay? Now, as the income has, not the income, your income is the same, I'm sorry, as the price of apples went up, you can no longer get as many. So now, if I would be to draw the new indifference curve, let's see, I can do it probably this way. Let's say it would be something like this. So this would be your new optimal bundle, right? Now we're consuming fewer apples, but also fewer bananas. Now we can decompose this into the substitution and the income effect. First, the substitution effect means that because the price of one of the goods is now relatively more expensive, you would start buying more of the relatively cheaper stuff. So apples got more expensive, bananas are relatively cheaper, which would mean you would likely start moving towards more bananas. So how we find the substitution effect, we pretend that we want to be just as happy as we used to be. So this is the utility of, let's say, 20. Now this one, let's say, corresponds to 10. Okay, now we want to hold the utility the same at 20, where we used to be. I want to be just as happy, which is all the points along this indifference curve give me the same level of utility. So I want to know if I wanted to stay just as happy, but the prices of apples were different relative to the bananas, what bundle would I use? So the price ratio of the price of apples and price of bananas is the slope of the budget line. So what I want to see is if the price ratio was the way it is now. So this is, I'm sorry, it's not very good. Parallel to this, it would now be tangent at a point like that. Because I have the original budget line is tangent here. Now, with the new budget line being like this, I would be tangent somewhere here. So moving from here to here along the same indifference curve, just assuming that the ratio of prices now is more in favor of bananas because the apples got more expensive, this would be the pure substitution effect. I am holding utility constant, but if apples are now more expensive, I would be shifting towards more bananas and fewer apples. The problem is that this bundle I can no longer afford. This would be if the prices changed, but I don't have enough money to purchase this bundle. Now we shift that pretend price ratio back to where the budget constraint actually ends up, and from this point to this final point, this is the pure income effect of just the parallel shift. So the substitution is we hold utility constant and just see how would our consumption change if the prices were different. So because the price of apples have decreased, now the marginal utility of apples divided by the price of apples versus the marginal utility of bananas divided by the price of bananas, it used to be equal, but now since price of apples went up, this is now smaller, right? So that would say eat more bananas, which would then start reducing the marginal utility until we would get the equality again. So that's the movement up here. Just because the price changed, we eat more apples. But the effect of now not having enough money left over because apples are more expensive, I can't afford even as many bananas because I just it all costs more. This is the income effect. Okay, now the tax stuff. Okay, let me see. Let me move to a new slide. I don't know if that works now, but hopefully it does. Okay, so now there is a tax on apples, right? So you have demand, you have supply, quantity, price. There is a 0.1 tax that's imposed, and it says it raised 100 million in revenue. So this has to be times 0.1, so this has to be actually one more zero. But causes 125 million loss of consumer and producer surplus. So what it means is, what did we lose in surplus? This is now my consumer surplus. This is the producer surplus. What is lost is this entire piece. Correct? This is all lost. That's no longer surplus. But the point is that this is the tax revenue and this is the deadweight loss. So what they're saying, there is 100 million worth of revenue, and that means since there's 125 total loss of surplus, the deadweight loss is 25. So hopefully that explains that question. Okay. As far as the pollution goes, it is the marginal cost and marginal benefit. It is not, the answer is not A until everything is internalized, all the negative externalities. It is literally, sometimes there could be the negative externality, which is fine, but we would still be willing to accept that pollution as long as the savings we get from the pollution is bigger than the cost that we're bearing. So it is just on the margin. Okay, as far as the firm ABC goes, so you have 3 firms. Each of them are producing 100 units and selling at $40, right? So the total revenue is, yes, 300 customers times 40, so they have a revenue of $12,000. Now, after they change the price to 30, these guys do not get any more customers. This guy does. So you know that along the demand curve, or you should know, this is your demand curve. We knew that at the price of 40, there was 300 demanded. At the price of 30, there is 350, right? So as the price changes along the demand curve, what happened here? This is what we lost in revenue because of dropping the price, right? When the price was 40, this is my revenue. Price times quantity, 300 times 40. That's your total revenue. But we lost this. This is the negative price effect, because now that we dropped it to 30, we had to discount all of them. So the revenue under 30 is 30 times 350, which should work, I think, to 10,500. So we lost this piece of revenue, but this is a positive quantity effect. So what we lost on the price effect, this is 10 times 300. So that was a loss of $3,000 in revenue. But we had picked up 50 units times 30, which is 1,500. So in total, we have a negative 3,000, positive 1,500. So this is the quantity effect. This is the price effect. So the net is a loss of 1,500, which is exactly what we saw from here to here, right? But why did firm C like it? Because firm C has the quantity effect, which is positive. They captured actually all of this. They captured the entire quantity effect because the quantity didn't change for firms A and B. They got all those extra customers. So they had a total of 1,500 of extra revenue to firm C, and individually they only lost 1,000. So they actually benefited by $500. These guys each lost. Okay, hopefully this helps. I think that's the final. Yes, that's the final question.